And I don't know if you have further questions, but we have time. It's not a really long lesson today, but the lesson is about material that I think you really need to practice a lot with. So any extra time we have is going to be really valuable for us today. Does anybody have any final questions or further questions regarding any of these problems that were assigned from yesterday's lesson as practice problems? No? All right, so we're going to move on today and delve into the exciting world of rationalizing binomial denominators. So you will need to open up your books, please, phones away, to, I think, page 10. Is that right? So we do know that, according to this rule we have in mathematics, we do not want denominators that have radicals in them. For some reason, and it's really not important, I'll tell you right now, it's more about a skill, because if you eventually move on and take calculus, like beyond 30-1, you take math 31, we need to know how to rationalize things for calculus reasons. So this is where it fits into the high school curriculum. What is a binomial denominator? A binomial denominator would be a denominator that has two terms. So a plus b is a binomial. X minus 2 is a binomial. But those two binomials that I just gave you, a plus b and x minus 1, I forget what I just said, those do not need rationalizing because they don't have radicals in them. When you're talking about a radical denominator that requires rationalizing, it might be something like 2 root 3 plus 5. That would be a denominator that is in need of rationalizing, that is also a binomial, and you don't know how to do that yet. So that's what we are learning today. As a warm-up, let's remind ourselves how to rationalize a denominator that's a monomial. So if I said simplify 4 over root 6, maybe I will say this explicitly. When I say simplify, you understand that in that word simplify includes rationalizing denominators. You're expected to know that. So I can take 4 root 6 and multiply the top and the bottom of this expression by root 6. Not a really difficult problem. This is 4 root 6 across the top, and root 6 times root 6 across the bottom just gives you 6. Of course, now you have a coefficient of 4 on the top and a coefficient of 6 on the bottom, so I can reduce those down and get 2 root 6 over 3. And we're done. You cannot simplify root 6 because the only factors of 6 are 3 and 2. 2 over 3 is reduced as far as it will go. You certainly don't want to get caught and do something wild and crazy like canceling the 6 with the 3. You can't do that because the 6 is part of a radical and the 3 is not. In other words, the 6 is a radicand and the 3 is a coefficient. So if the denominator needed to be rationalized as a binomial, we need to multiply the numerator and denominator by something called the conjugate. And as I'm looking at your unit handout, I saw that something crazy happened with the printer, so we're going to have to fix that. That is not an alien language. I will explain to you what that actually means in a second. But what is a conjugate? This, I believe, printed out well. Here's an example of two binomial conjugates. 4 root 6 minus root 3 and 4 root 6 plus root 3. And what I would say to you is they are conjugates of each other, which means if I said, what is the conjugate of expression 1? You would say the conjugate of expression 1 is expression 2. If I said, what is the conjugate of expression 2, you'd say expression 1. They are conjugates of each other. So you can recognize conjugates because essentially they have the structure a plus b and a minus b. These would be two binomial conjugates. So a is positive in both, but then it's plus something in one and it's minus that same thing in the other. By the way, these are rational binomial conjugates because they don't have any square roots. Okay. You know what? No, I won't do that. So in the space below, simplify the product of 4 root 6 minus 3 and its conjugate 4 root 6 plus 3, and then I've typed this out for you, but unfortunately this is where the photocopier decided to spaz out on me as I sent it from my computer to there. I don't know what those symbols are or what happened there, but this is what we're talking about in question 1. So we want to simplify this, but you know what? I am going to do this. I'm going to go back to this, and let's just walk away from the lesson for a second. I told you that these are conjugates of each other, and I said they are rational conjugates, right? Correct? Because there's no radicals. Let's imagine that A was a radical. Let's imagine that A is actually root something. Okay? If I FOIL this out, first, outer, inner, last. What do I get? First is A times A, which is A squared. Outer is A times negative B, which is negative AB. Inner is A times B, which is AB. And last is B times negative B, which is minus B squared. And I want everybody to focus on the outer and inner and the fact that they are exactly opposite of each other, aren't they? In fact, the outer and inner together will give us 0. And I want you to ask yourself if that's always going to be the case when you multiply two binomial conjugates. We can try another one. We can try this one. These are binomial conjugates. So if I look at my first, I'm going to write this below where I have a bit more room. First, outer, inner, and last. My first is, and be very careful here, I know from experience how easy it is for students to make a mistake. 4 root 6 times 4 root 6, which is 16 times 6. Be very careful. The 4 times the 4, those two numbers are conjugates. 4 times 4 is 16. Root 6 times root 6 is root 36, which is 6. And I don't have a problem with you having an intermediate step here and saying 16 root 36. In fact, I would prefer that you do that if it means you're not going to make a mistake. What is my outer? My outer is 4 root 6 times root 3, which is 4 root 18. So over the past couple days, we've kind of warmed up to how we multiply these terms together. My inner is 4 root 6 times negative root 3, which is negative 4 root 18. And my last is root 3 times root 3, which is root 9. I'm not sure that you would really write root 9. You'd probably just delve right into 3. And I made a mistake. Who wants to tell me what the mistake is that I just made? You know, Rick? No, that's not it. That's actually not it. You know? It should be negative. Because I am multiplying a negative by a positive. And this is 0. And I hope you start to see why your outer and inner is always going to be 0 when you have conjugates. Because your outer will be A times, say, negative B, and your inner will be A times positive B, so you'll get opposite things. And this is why I would say to you, so our answer here is, let's see, 16 times 6 is 96 minus 3. How is my arithmetic there? 93? Okay. here is the important point. Well, there's a number of important points. This was irrational, and by multiplying it by its conjugate, we've turned it into something that's rational. It has no radical anymore. And what I would tell you, I'm going to go back to this, is whenever you're multiplying conjugates, you don't have to FOIL. And I've been saying this for years. When you multiply two binomial conjugates together, you FLA. You do the first, you do the last. You don't have to worry about outer and inner. So, we've done this. We get the number 93. What do you notice about the product of two irrational conjugates? The product is rational. This is the most important part of this lesson so far, because we are trying to rationalize expressions, and I've just shown you that when you multiply two binomial conjugates together, you get a rational number. 93 is rational. It's exactly 93. It's not a square root. So, how would we simplify this? Well, first of all, I want to just throw something else your way. If this were 6 over 2 plus 3, root 3, could I reduce the 6 and the 2 down, do you think? No. I can only reduce down if it's a factor of the top and the bottom, which means I'd have to cancel it out of every term on the top and the bottom. So I just want to get that out of the way. Can we simplify root 3? Well, no. Root 3 is root 3. You can't break it down any further. Do I have a common factor on the top or the bottom that I can divide? No. So all that's left is to rationalize this denominator. So I have 5 on the top over 2 plus root 3. And I am going to multiply the top and the bottom of this expression by whatever it takes to rationalize the denominator. And what it takes is multiplying by the conjugate of the denominator. Because two binomial conjugates multiplied give you a rational thing. So I'm going to multiply the 5 by 2 minus root 3, and I'm going to multiply the 2 plus root 3 times 2 minus root 3. Again, I want to point out to you that this thing right here, 2 minus root 3 over 2 minus root 3, is equal to 1. So by multiplying the original expression by 1, you're not changing its value, you're just changing its appearance. So what do we get on the top? I'm going to leave the top as 5 times 2 minus root 3. I'm not going to multiply that out. And in a minute, I'm going to explain to you why that's a good idea to leave it alone. And I see a few of you erasing now because you probably started writing 10 minus 5 root 3. Let's just leave it that way. On the bottom, what do I get? I get 4 minus 3. This 4 is the 2 times the 2. And then we have minus root 3 times root 3, which is 3. So this is a little slippery to wrap your head around, because when you look at the two 2's, they become a 4, but when you look at the two 3's, they become a single 3, because the 3's are actually root 3's. You with me? You know, if you wanted to, in your FLA, you could go 2 times 2 is 4, minus root 3 times root 3 is root 9. If you wanted to, you could write that. But root 9 is 3. So this worked out actually brilliantly, because now what we have is 5 times 2 minus root 3 over 1. 4 minus 3 is 1. So our answer is 5 times 2 minus root 3. Now, why did I want to leave that 5 factored out? The answer is really simple. If, and I don't know how this would happen, and you don't need to worry about how it would happen. But if you didn't get 1, but you say got 15, then you can cancel the 5 with a 5 in the 15. And we're, in the next unit, going to really delve into the idea that factored is better. When you have a rational expression, which is a fraction, a rational expression is a fraction where you have a top over a bottom, a numerator over a denominator. It's better if everything is written in factored form. Okay. Anyway, that's the answer. 5 times 2 minus root 3. If you were writing an exam and you saw as a choice 10 minus 5 root 3, of course that's the same thing, because I multiplied the 5 through. Let's take a look at the next one. 12z over root 8z. Now, if you look very carefully, you can see that square root sign extends over the z. And when I write it this way. I would like to start a campaign in the world to change the square root sign to have that little thing hanging down so that we all know where it ends. So far, I haven't got anybody that's on board with me. It's just not that important. Minus 3. I think that looks better, though, right? You can see it's clearly the square root of 8z, not the square root of 8, then times z. I need to rationalize this. Well, just a second here. Could I simplify root 8z first? I could, because root 8 can be simplified. But I'm not so sure I want to, because I am about to multiply top and bottom by the square root of 8z plus 3. And I don't want to be wasting a bunch of time doing something that really is going to make my life more complicated on the bottom, because on the bottom all I have to do is take root 8z times root 8z, which is 8z, minus 3 times 3, which is 9. You know, I realize, and I hope you realize, I should simplify the root 8 on the top. But if I simplified it on the bottom, it would just get uglier and uglier. It would get messier. On the top, I have 12z times root 8z plus 3. So on the side here, I'm just going to simplify root 8z by extracting the perfect square of 4 and taking the square root of it to get 2 root 2z. And I get 12z, and then it's multiplied by 2 root 2z plus 3 over 8z minus 9. I'm really, with this stuff leading up to the next unit, when I ask this question, can I cancel anything? I see a 12 and an 8. Can I divide the 12 by 4 and the 8 by 4? Am I allowed to do that? And the answer is no. Although 12 is a factor of the top, because it's 12 times times times, 8 is not a factor of the bottom. It's 8 times z, and then, oh man, minus 9. That screws everything up for canceling. It's got to be times, 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 times for you to cancel. So we're done. If you wanted to, I'm not sure whether you do or not, and I guess I'm telling you it's your decision. You could multiply the 12z through. But I don't believe there's anything to be gained by doing that. Factored is better. Look carefully at where the square root sign on this one ends. It does not extend over the p. So when you rewrite this, which I think is always a good idea, it's root 6 and then p minus 3. And we're going to multiply the top and the bottom by the conjugate of the bottom, which is root 6p plus 3. On the top, 12 times root 6 p plus 3. Leave it in factored form. In other words, don't multiply that 12 through. On the bottom, this is a bit of a brain buster on the bottom. It's not difficult, but there's a lot going on. It's root 6, then times p, times root 6, then times p. So the root 6 times the root 6 is 6. The p times the p is p squared. And then I go negative 3 times negative 3, which is negative 9. Let's let that roll around upstairs for a few seconds. Does that make sense? Okay, good. Can I cancel the 12 and the 6? No. And this is, again, I told you the other day, I'm going to be saying this dozens of times. It might be hundreds of times. You only ever cancel something if it's a factor on the top and the bottom. And you can identify a factor as being something that is in brackets times everything else. Is 12 a factor of the top? Yes, it is a factor of the top. Is 6 a factor of the bottom? No. But we can factor the bottom by removing is maybe a bad thing for me to say. By factoring a 3 out. There's a common factor between 12 and between 6 and 9 on the bottom of 3. And it would leave me with 2p squared minus 3. Can I reduce 12 over 3? Yes. And here's the real reason why. I know that maybe some other teachers would just go, wow, it's 12 over 3, it's 4. Here's a deeper understanding of what's going on here. The reason you can reduce that is 12 is 4 times 3. So is 3 a factor of the top? Yes, because it's in brackets times everything. Is 3 a factor of the bottom? Well, yeah, it's the entire bottom, so it's a factor of the bottom. And this is why you were allowed to start slashing and burning numbers like that. It's because you're getting rid of common factors. And I hope that if I say that enough times in this unit, that you don't suffer hardship in the next unit. The next unit can be really difficult. But if you remember to only cancel common factors, it's great. So this is 4 times root 6 times p plus 3. And this is our answer. Everybody, this is precisely why I'm telling you at this stage to leave the 12 alone. Yep.
What happened to the 2p squared underneath it?
It disappeared in a black hole in some part of my brain. Thank you. We have a 2p squared minus 3. Thank you, Ariana. So this is over 2p squared minus 3. Anybody else catch that? I'm sure many of you did. And don't be afraid to ask that, because sometimes it will go away for a reason, but in this case it disappeared from my brain. This is precisely why I said up here, where we were multiplying the top and the bottom by the conjugate, don't multiply that 12 through. Leave it exposed out there, because you can only cancel factors. And if it's in factored form, that's what you're going to be looking for, or factors. Bless you. So that's the answer. Bless you again. And you can't cancel anything here. I know it's really tempting to start, canceling the 3's and the 4 over the 2, and you can't do it because they're not factors. Holy smokes. A binomial irrational over a binomial irrational. So let's rewrite it first. 3 root 6 plus root 5. This is divided by 2 root 6 minus 3 root 5. And we are going to multiply the numerator and the denominator by the conjugate of the denominator. Why are we multiplying by the conjugate of the denominator? Because that's the rule. That's what always works to eliminate the radicals from the denominator. So the top, everybody, is going to be determined by using FOIL. The bottom is going to be determined by using FLA, because the bottom is a product of conjugates. The outer and inner don't matter. Look, if you want to calculate the outer and write it down and the inner and write it down, that's fine, but you're going to discover they will cancel. Okay, across the top, 3 root 6 times 2 root 6 will give me 6 times 6. Let that sink in, that the product of this and this is 6 times 6. I multiply the coefficients. 3 times 2 is 6. I multiply the radicands, so I get root 6 times root 6, which is root 36, and root 36 is 6. Continuing on, my outer will be 3 root 6 times 3 root 5, which is 9 root 30. My inner is root 5 times 2 root 6, which is 2 root 30. And by the way, when I get to the end of this FOIL, I'm going to double check each of the 4, and I would recommend that when you're doing this, you do the same thing. When we get into Math 30 and calculus, for those of you that move on beyond that, that's what I will always be telling people. As the algebra gets deeper, you do every step twice. You do it, and then you check it. Root 5 times 3 root 5 is 3 times 5. So outer is 3 times 3, which is 9, and root 6 times root 5 is root 30. That's correct. Inner, I've already checked the first. Inner is 2 times root 6 times root 5, which is 2 root 30. And last is 3 times root 5 times root 5. Root 5 is 5. On the bottom, we have 4 times 6. Boy, this is where you'll make a mistake. When you multiply something like this by something like this. If mistakes are going to be made, that's probably the likely location. 2 times 2 is 4. Root 6 times root 6 is 6. It's always minus for conjugate products. 3 times 3 is 9. Root 5 times root 5 is 5. How does it look? 60 eyes are better than 2. Okay. I can clean up the top. I'm not sure I want to rewrite this with a 36 and a 15. I can figure out what 36 plus 15 is, I hope. 41? 51. Good. 51 is what you get for the 6 times 6 plus 3 times 5. We also have, oh, this is nice, we have common terms. Maybe that's not the best thing to say. We have similar terms. We have root 30s that we're adding together. So I get 51 plus 11 root 30 over, what do we get? 24 minus 45. I got to see this in action. Negative 21. Okay. So, can I cancel anything? Well, even if, is 51 divisible by 3? Oh, 51 is divisible by 3. 21 is divisible by 3. Can I divide 3 out of each of them? No, because 3 is not a factor of the top. If 3 was a factor of the top, 11 would be divisible by 3 as well, and I would be able to factor the 3 out of the top. So this is it. This is our answer. I'm not a real fan of writing it that way. Sorry? Who's speaking? Yeah. Can't I factor? Can I factor the 3 out of 30? No. I can factor root 3 out of root 30. But I can't take this 11. Let's just talk about the root 30. I can't write this as 3 root 10. Right? It's not 3 root 10. It's root 3 root 10. And let's go back to quadratic equations in the quadratic formula where we canceled stuff as long as you canceled these 3 things. You remember that? That's the equivalent in this unit of saying you're allowed to divide out a common factor as long as you divide it out of a coefficient, a coefficient, a coefficient. Is the speaker buzzing? Okay. So I can't factor a 3 out if, let's put it this way. If I said I'm going to, out of the top, factor a 3. Oh, that's cool. I didn't know it did that. If I factored a 3 out of the top, I would have 17 plus something. And the thing that I would have to be left with would have to be something which, if I multiply by 3, gives me 11 root 30. The only thing that would make sense here is this. I mean, if I multiply this thing by the 3, the 3's will cancel and I'll be left with 11 root 30. But the bottom line is I can't factor numbers directly out of a radical. Now, if this was root 90, then I could write it as root 9 root 10, which is 3 root 10. Then that 3 has been freed from the radical. But it would have to be something squared inside of the radical. Does that make sense? Okay. I do have to finish something here. That is our answer. But I don't like having a negative in the denominator. It's not a rule. It's just it looks goofy. So you could write it this way. This is maybe what your textbook would do. I like this better, but I'm not a real fan of this either, this negative just kind of hanging in front of the whole thing. Because mathematically, what does it mean? It means the whole thing is negative, but algebraically, you don't know what to do with it. I would rather have this. I would rather write it that way. You could certainly multiply that negative through and write negative 51 minus 11 root 30, but it's all about preferences. Then I would have 2 negatives. I'm not so sure I want 2 negatives. Anyway, I think mathematically you should understand why these 3 expressions you're looking at here are all the same anyway. That's it. This is some of the work here has to be very careful and deliberate and organized and thoughtful. You can't just rush through this stuff. So there's a whole bunch of questions on the next page, on page 12 of the unit handout. You have boatloads of time today, more time than we normally have in class. You have at least 40 minutes to work on this stuff. And tomorrow we're going to be looking at solving equations that have radical expressions in them. So get to work, please. I'm going to take attendance and then I'll be around to help you out.